In this video, I'm going to be presenting a quick way of doing linear models in R. Okay, so I've done a hypothetical example. So I've created 100 random numbers, right? So that's what RUnif does in R. So let me just run that. Okay, so just so that I show what it is. So these are all the 100 random numbers. Okay, so it's just a uniform number. I just randomly generate. But now the model, I'm telling you that the model is going to be y is equal to 1 plus phi times x. Okay, so that's a model that we need to estimate. But of course, because I want to make it a bit more interesting, I want to add some random noise. Okay, so the random noise term is this R norm that I've added. Okay, so R norm is going to be normally distributed random numbers with the mean of 0 and variance of 1. Okay, so the standard normal distribution. I'm just adding noise over there just to make the problem a bit more interesting. So the question is, so once I run this bit, can I recover those coefficients? And the way to do that in R is you run the linear model. So that's what LM stands for, and you go y tilde x. Okay, so it's saying for me to model, I need to model y in terms of x. So let me just run this one. So it has all the information that's stored. Now if I just type in a, it will give you the coefficients and the intercept. So in this case, I got an intercept of 1.4 and the coefficient of x was 4.0. So it was close in some sense, right? So of course, if I got more data, I should be able to see this. And I'm guessing the reason that I didn't get great data was because even though this was random noise, the fact that it has a variance of 1, whereas x the data is between 0 and 1, that probably threw this thing off by a bit. Okay, so the noise is actually quite large compared to what the actual x values are. So that's probably why it didn't give me great results. But anyway, let's just put that aside. Now, usually you're not concerned just about the intercept and the coefficient. You want to do some hypothesis testing. So, for example, you want to see if the model is significant, if the coefficients are significant, and to see that, what you go summary of A. Okay, so you run this command going summary and in brackets whatever you stored your model in. Okay, so it gives you a bit more information. So it gives you the quartiles, right? But what I'm interested more is the intercept. So the standard deviation, the t-values, right? It tells you what the p-values for those are, right? So the p-values, as you can see, it says it's less than 2 times e to the negative 16, so which means it's quite significant. It tells you what the r squared was. So r squared was it was, like, I wouldn't say poor, but like it's 56%, right? So not that great. And the adjusted r squared was 55%. Now here we go. Is the model significant? If you look at an F statistic, you can see it's 124.7. Good thing about R is that it just tells you straight away what the degrees of freedom was, and there was 198. And p-value without any surprise is 2 times 2 and then 10 to the negative 16. Okay, so it's quite small. So the model is significant. So that was my tutorial on how to do linear models in R. So the main takeaway message is to use LM, and it's y tilde x, right? So the syntax. If you have any questions, let me know, but I hope you enjoyed that. Thanks for watching.